Hi, welcome to Philae by Norizal and Fina Muhammad Nampia.
Now we want to know two things about this oscillating block. What kinds of energy does it have, and what's its maximum velocity? To better understand what's happening to the block, let's start with the energy. As the block compresses and stretches, the spring by the kinetic energy and potential energy come into play. Kinetic energy is the energy of motion, that is given by k is equal to half mv squared, where v is the velocity of the mass m. Hence potential energy is stored in a stretched or compressed spring, that is given by U is equal to half kx squared, where k is the spring constant and x is a distance. At any point during the oscillation, the total mechanical energy E of a mass spring system is the sum of the kinetic and potential energies. As long as there is no friction, the total mechanical energy E remains constant. As the object oscillates back and forth, energy continuously changes from potential to kinetic and back to the potential energy. When a compressed spring is released to the full amplitude A and negative A, the energy is stored in spring as potential energy. At these points the block stops momentarily as it changes direction, so the velocity v is equal to 0. Thus, the total mechanical energy E is half times k times the amplitude squared. Now as the block moves towards the middle, that is at the equilibrium point, the kinetic energy is start to increase because it's moving faster and faster. And at the same time its potential energy decreases, keeping its total energy the same. And exactly in the middle of the block motions at the equilibrium point, its potential energy goes down to 0. The block is backward started, so the spring is no longer pulling on it. The kinetic energy on the other hand reaches maximum, which means at that point the total energy of the block will be equal to half with its mass times its maximum velocity squared. Now we have two equations for the total energy in the oscillating spring which we can combine into one equation. If we use algebra to move around these variables, we can start to answer the second question we had about the block. We want to know the block's maximum velocity. And this equation tells us that the maximum velocity is equal to the amplitude times the square root of the spring constant divided by its mass. We also want to know what is the velocity when the block moves towards the distance x. At this point, the energy is part kinetic and part potential because energy is conserved. So that, we can write, solving for the velocity v, we find that v equal to the square root of the spring constant divided by its mass times amplitude squared minus x squared. Today you have learned about the energy in SHM and the maximum velocity of the block. Thank you for watching. See you on the next video.